Hello Tobias. Hello. Thank you for watching. So today I have to finish the PCB layout for this board. Nothing special, but what is the issue here is this BGA package. This fine pitch BGA package with 0.5 millimeter pitch, not so crazy, but the hello Ayub, but the manufacturing should be if not low cost, affordable. I just studied the capabilities of the JLC PCB, the absolute minimum drill in the multi-layer board is 0.15 with, of course, some extra charge, but should be acceptable. In the case I should done something like via in pad, not optimal, but I am not sure yet, and I have to make some math, do some math. And speaking of clearances for standard plating, there is a 0.1 millimeter minimum track and spacing, with some hint that there can be 3 mil as a acceptable minimum track width and spacing for BGA fanouts, which is exactly what I need. So 3 mils is something like 0.075 millimeter, which should be enough. If you can see, I have to fan out these. Of course, the fencing pads are not an issue, because yeah, I can go straight away from the package, but I have to fan out these four pads here. And as you can see, here is a standard net class, and there is no chance to fan out a track with the standard thicknesses. So let's set the minimum 3 mil for the BGA fanouts into the net classes. So let's open the board setup. Here is the net classes section, and I will create a special class. Let's call it BGA. No. I will edit the default clearance, because if I would create a special net class, I should assign the classes to all nets, and as you can see, there are basically almost all nets should be assigned to that BGA class. It means I can directly use the default net class, and the result is the same but without the extra work. So clearance 0. Let's call this is the size of the inch in millimeters. This is mil, which is 1/1000 of the inch, and I want 3 mils. So 0.762 millimeter is my clearance. The same for the track width. This is crazy thin. This will be 0.2 because here on GLC PCB there is, notice, by default I use 0.25 drilling with 0.45 as a via size, and I noticed that here in the minimum multi-layer via hole size diameter is 0.15 for extra price, extra cost, but here is some nodes. Node number 2, preferred minimum via hole size 0.2. It seems like I'm well above the limit, and it seems that 0.2 should be okay, and if I add 0.1 as a thickness of the via, it means 0.4 is the size of the via and 0.2 is drilling. So I will edit the default via size as 0.4 and via hole 0.2. Micro vias will not be used and differential pair as well. So let's see the default net class, which is here, and it reminds me to edit no page settings, board setup. It reminds me to review the entire board setup. This will be the stack up, and I noticed that for multi-layer boards sometimes there are some special numbers. It means smaller numbers. So I will create it as a 4-layer board. This PCB will be 4-layer board with the ANIC preferably, and solder mask expansion 0.7 as a standard. Let's see what we'll do with the BGA pads. If something bad will happen, I will change it to some smaller number. Constraints, minimum clearance, as we said. This I can keep 0, but I don't like 0 as a minimum. Width or clearances. I can here change. Yeah, I have to change to 0.4. Minimum copper to hole clearance. Copper to hole I have to review. Copper to hole. Drilling, not drilling. I need clearances, traces. Where it is? Here, no, here is pad to track. Tight it through hole to track, this is it. Copper to hole, yes. And this is 0.28. 0.35 is recommended, so here 0.5 can be left. Minimum through hole 0.2. Hole to hole clearance. This will be probably the same as PTH2 track. Yeah, I will keep it 0.28. Yeah, let's see 0.7 here. Let's see what it done. Yeah, this is the solder mask expansion. As I said, it makes more harm than benefit. 0.5. Yeah, let's see. So here is the minimum. It's still too much. Let's review the package, because I can always go with smaller pads. I'm not sure where was the description of the package, because yeah, here, length pattern, application note. This is a general rule, and here is ball pitch 0.5. This is our case. Acceptable pad diameters 22, 0.22 to 0.28. Recommended 0.25. Okay, but acceptable is 0.22. So I can change the size of the pads to 0.22, which is still acceptable. But first, let's review the current state. The current state is 0.28. Okay, it's too big. It's good, it's too big. So I will go with the lowest acceptable pad diameter, 0.22. I have to change at least these four for a test, and if there is some reserve, some clearance, I will make the pad bigger, because smaller pads means more manufacturing issues. So let's start with this. I will update the footprint on the PCB. Yeah, this is the these four pads were updated, and now can I? Yeah, this is it. And as you can see, there is still some distance. The fun fact is that the thickness of the track is so thin and the pad is so small that even with the finest grid I can't measure the distance directly, so I have to help myself. So here is the let's say I'm slightly off grid, but the distance from the pad to the edge of the track is the same, but roughly the same. So this is 0.1 is the clearance, and I have 3 mils, which is 76. So I have 0.024 millimeters reserve. So I can go with the I have 0.22 on both sides. So if I make it 0.24, which means 40, yeah, I can try 0.24. I'm not sure now, but no. This 0.24. 0.24. Thank you for watching, Wellington. Thank you for your message. I'm not sure if my knowledge is or should be or will be helpful to you. I'm just thinking aloud when I'm working on the fan out of this fine pitch BGA. I have to go slightly harder to the limits of the PCB manufacturing, because otherwise I wouldn't be able to fan out the inner pads. So now I'm tweaking the size of the pads and playing with it to keep the optimal dimensions. My requirements: the biggest pads possible and the bigger possible and the largest possible thickness of the PCB, thickness of the track. So I'm still 24. I'm still able to fan out the 3 0.5mm track, which is good. So now I am, because 0.24 pad is good, I don't need bigger, this is almost the optimal size. So now I will make the tracks thicker. So net class, and I will use 3.5 times 25.4 divided by 11 by 1000, 0.889, which is 3.5 mil. 3.5 mil. Let's check it again. Yes, and still, and there is still some reserve. So I can say that I can go with 3.5 mil for the clearance, which should result in a standard, as you can see here, standard manufacturing, where it was here, 3.5 mil / 3.5 for multi-layer, minimum track width and spacing, and 3 mil is acceptable for BGA fan-out. So now I am on the safe side. Let's review. 3.5, yes, and now can I fan out? No. 3.5 is too thin. So I can go to, I don't know what is better for me, if the smaller pads or a lower clearance. I will go with the lower clearance. Yeah, because if they say that BGA can be fan out with 3 mil tracks, so I will go with the 3 mil 762. It was, yeah, 762 clearance. Okay, yeah, is it good? Okay, so this is my setup. 3 mil track, 3.5 mil track, 3 mil clearance, and I think that here I can use my standard size of the via, 0.25 / 0.45. So let's fan out it. It seems to be possible to do it. So the most important thing is now to check the datasheet, because there should be some preferred PCB layout. Yes, it is, and they say that, you can see, they use the vias as instead of going in between pads, but it's completely, yeah, I need to finish change of the PCB of the package. 0.24 for all pads, and I think my way for fan out the inner pads with the track in between the fencing pads is better than to use vias in between the pads, because the distance is too small, the clearance in between the inner pads. I think using micro vias is definitely more expensive feature than to use a smaller clearance. Let's see. If I measure the distance, yeah, 0.46, including the clearance. Yeah, so it should be 0.30 VIA. This is micro VIA. I don't want it. This device is a single inductor multiple output converter with rather small output current. This device is designed for wearables and small devices, so I don't need such a big polygons for the fencing pads. I will use the standard tracks, and I will fan out the inner pads in between the fencing pads. Probably not the best strategy, but for me it will work because I don't want to spend a fortune on this PCB. So let's define some requisites besides the default net class, at least this one. Yes, so I can go here. C2 is enable C3. Yeah, this is the LXB important pad, and the other one is D2 C3, D2 and C3. So D2 C3, and the position of the inductor is okay. So they want me to go in between pads of the input capacitor to connect with the inductor. So let's see if it's possible. Something like this. Yeah, the ground. Yeah, okay, the ground directly with the capacitor, and then you have to use some polygon in between. Okay, the inductor connected with all these two. C3, we say. D2 C3. Yes. Yeah, it's thin. I can see it. But what can I say? What can I do? I can do something like this. I have to make some space here. Get this against my plan.
unlimited listening, head over to brain.fm or follow the link in the description below.
Okay. Not great, but what can I do? Oh, here is the bootstrapping. Not good, not good. I forget the bootstrapping capacitor. I will try to go from here. Basically, I can, but as you can see, not here. I need a 𝗲𝘁 here. There is no space for 𝗲𝘁. Let's play. Let's try to find a way. D4 is, what is D4? Oh, another important pad. To be connected with A2. D4, A2. Okay. There is no space around the 𝗲𝘁. Terrible. It's terrible. Okay. I have to go heavier for the bias too, 0.4, 0.2. Let's try. Let's try. It means then that I have to change the existing bias as well. I can do it this way, or I can do it this way to update it using the hotkey. So it worked. You don't like it, I don't like it. But what can I do? What can I do? I don't know why KiCad wants to update the entire net. Back or something. Oh, this is awful. It looks like the KiCad wants to help me, but it actually doesn't. Okay, let's connect the important tracks.
unfiltered.fm or follow the link in the description below.
Hello, Said. Thank you for the question. I can forward you to some RF engineers. Let me. Yeah, I can reply with a comment here. Please send me a DM and I will send you the name of the RF engineer that can help you. Okay?